Coordinate Geometry 1. In this particular video lesson, we are going to consider the straight line. So if we have two given points A, B with coordinate x1, y1 and x2, y2 respectively, then we can always find a distance between point A and point B. So this is given by the distance formula. AB equals square root of x2 minus x1 all squared plus y2 minus y1 all squared. Then we can also find the midpoint of the line segment PQ with coordinate x1, y1 and x2, y2 respectively by finding the sum of the first x coordinate and the second dividing by 2, and also the sum of the first y coordinate and the second dividing by 2. Then the gradient of a straight line is given by the change in y over the change in x. So gradient m equal y2 minus y1 over x2 minus x1. So if we know the angle that the straight line makes in the positive direction of the x-axis, then we can always find the gradient of that line when we take the tangent of the angle, because it's going to give us the ratio change in y over the change in x. Now you have to take note of this. This is measuring from the straight line to the positive x-axis. We have the equation of a straight line in the point slope form. If we know the slope of this line m and it is passing through the point x1, y1, then the equation is given by y minus y1 equal m into x minus x1. Then also, if you know 2 points on a straight line, we can use the gradient formula to determine the gradient of this straight line, that is y2 minus y1 over x2 minus x1. Then after that, we can use the formula, that is y minus y1 equal m into bracket x minus x1, or y minus y2 into bracket m times x minus x2. So we use any of these points and we get the same result. If two lines are perpendicular, then the product of their gradients, that is the first gradient and the second gradient, will give us -1. Then if they are parallel, it means their gradients are the same. So m1 equal m2. So let us now take our first work example from WASSCE 2017 NAVDEC. We know the gradient of the line to be 2 and it is passing through the point -2, 3. So let's call it x1, y1, and this is our m. So we use the formula y minus y1 is equal to m into x minus x1. So we just sub in these values. So we have y minus y1, which is 3. Then we have the gradient, which is 2 into x minus 2. So we simplify this to obtain y minus 3 is equal to 2x plus 4. You know, negative give us positive. So we have y to be equal to 2x plus 4 plus 3. So we simplify this to obtain y equal to 2x plus 7. Now let's take our second example. So we know the gradient of this line is given. It's not given, but we are given the angle and the intercept. So but we need to find the angle that it makes in the positive direction of the x-axis, which is 180 minus 30, and it is 150 degrees. So our gradient is given by tan 150 degrees, and this is equal to negative 1 over root 3. So we know the gradient and we know a point on the straight line, so we can use the point slope formula. Y minus y1 is equal to m into x minus x1. So we have the point 0,5, which is x1 is 0, y1 is 5, and we know our gradient to be equal to negative 1 over root 3. So we just sub them into the formula to obtain y minus 5 is equal to m, which is negative 1 over root 3, into x minus 0. So we have y minus 5 all multiplying by root 3 is equal to negative 1. So negative 1 times x will give us negative x. So we simplify that. Now we have root 3 y minus 5 root 3 is equal to negative x. So we simplify this further to obtain root 3y minus root 3y is equal to negative x plus 5 root 3. Now we simplify this further and we had C to be the correct answer. Let's take the example 3. Now we know how to find the intercept. So for 2y equal 4x minus 8, we know when x equals 0 we get the y-intercept. When x equals 0 we get a y-intercept. So for y-intercept x equals 0, we sub in x equals 0 into the formula or into the equation. So we have 2y equal 4 times 0 minus 8. So this implies that 2y is equal to negative 8 and y will be equal to negative 4. Then also for the x-intercept, y is equal to 0. So we sub in 0 into the formula to obtain 2 times 0 is equal to 4x minus 8. So we have 0 equal 4x minus 8, and this implies that 4x is equal to 8. So we simplify this to obtain x to be equal to 2. So we know the x-intercept to be 2, 0, and the y-intercept to be 0, 4, 0, negative 4. So we know 2 points now, x1, y1, and x2, y2. We can use it to determine the gradient. So we can now find the midpoint. So the midpoint is given by x1 plus x2 all over 2, then y1 plus y2 all over 2. That will give us the midpoint of that straight line. So we have the midpoint m is equal to 0 plus 2 over 2, then we have negative 4 plus 0 over 2, and this is going to give us 1, negative 2. Hence the midpoint is 1, negative 2. Now we have this one. We have two straight lines given to us, the equation of two straight lines, and we're told that they are perpendicular. So the first one is 3y equal 4x minus 1. So we can rewrite this as y equal 4 over 3x minus 1 over 3. So the gradient is given by m1 equal 4 over 3. That's the gradient of the first equation. So for the second equation, we have ky equal x plus 3. So dividing through by k, we have y equal 1 over k x plus 3 over k. So the second gradient m2 is equal to 1 over k. Now if these two lines are perpendicular, then m1 times m2 should be equal to negative 1. Now the m1 is 4 over 3 times the m2, which is 1 over k, is equal to negative 1. So we just solve for k, and if we multiply through by negative k, then we will obtain k to be equal to negative 4 over 3.